Sir Isaac Newton.
Born in 1642 in England, Newton was born in a small farmhouse in Woolsthorpe, a village in Lincolnshire, England. His birth coincided with the year of Galileo Galilei's death, another luminary in the history of science. Known for his groundbreaking work in classical mechanics and optics, Newton's contributions to these fields reshaped scientific inquiry and laid the groundwork for modern physics.
His insights into the behavior of light and the nature of motion were revolutionary.
Published Philosophiae Naturalis Principia Mathematica in 1687, laying the foundation for modern physics. Principia Mathematica, as it's commonly known, is considered one of the most important works in the history of science.
In it, Newton introduced his laws of motion and the law of universal gravitation.
Three major contributions: laws of motion, universal gravitation, calculus. Newton's laws of motion and law of universal gravitation provided a comprehensive framework for understanding the physical universe.
His development of calculus provided a powerful mathematical tool for solving problems in science and engineering. Newton's laws of motion revolutionized understanding of dynamics. Prior to Newton, there was no systematic understanding of how objects moved. Newton's laws provided a mathematical description of the relationship between forces and motion.
His first law states objects remain at rest or in uniform motion unless acted upon by an external force. Known as the law of inertia, this principle laid the foundation for understanding the concept of force and inertia.
Second law defines force as mass times acceleration, F equals ma.
This equation quantifies the relationship between force, mass, and acceleration, providing a means to calculate the effects of forces on objects. Third law states every action has an equal and opposite reaction. This law highlights the reciprocal nature of forces, emphasizing that interactions between objects result in equal and opposite forces. Newton's universal law of gravitation describes the force of attraction between masses. This law explains the gravitational force between any two objects with mass and provides a mathematical formula to calculate this force. Developed calculus independently of Gottfried Wilhelm Leibniz. Although there was controversy surrounding the development of calculus, Newton's work in this field was groundbreaking and laid the groundwork for future mathematical developments. Newton's work formed the basis for classical physics for centuries. His laws of motion and gravitation provided the framework for understanding the physical world until the advent of modern physics in the 20th century. Influenced fields beyond physics, including engineering and astronomy. Newton's principles are foundational in various scientific and engineering disciplines, shaping our understanding of the natural world and enabling technological advancements. Newton's impact on science is immeasurable. His contributions revolutionized physics and laid the groundwork for centuries of scientific inquiry and discovery. Knighted by Queen Anne in 1705 for his contributions, Newton's achievements were recognized by the British monarchy, and he was knighted for his service to science and mathematics. Served as president of the Royal Society. Newton's leadership of the Royal Society further solidified his status as a preeminent figure in the scientific community. His work laid the groundwork for Albert Einstein's theory of relativity. While Einstein's theory revolutionized our understanding of space, time, and gravity, it was built upon the foundation established by Newtonian mechanics. Newton's legacy continues to shape our understanding of the universe. His principles remain integral to our comprehension of the physical world and continue to inform scientific research and technological innovation. Considered one of the greatest scientists of all time, Newton's contributions to science and mathematics have earned him a place among history's most esteemed scientists. Died in 1727, leaving behind a monumental scientific legacy. Newton's death marked the end of an era in scientific thought, but his ideas continue to inspire and influence generations of scientists and scholars.